We are in module number 12. With module number 12, we're going to talk about evading IDSs, IPSs, honeypots, and firewalls. So let's have a look at the overview and see what we're going to be doing. So what we see here is we have several different areas, and we're going to start off with a summary of some of these concepts. So if you've never used them, it'll be a good time for you to figure out how they work. And then number two, we're going to look at some solutions. So there are a lot of companies that make IDSs, IPSs, firewalls, and honeypots. We're going to look at some of those. Number three, we're going to look at different techniques to bypass IDSs and firewalls. And then we're going to focus on bypassing NAC and endpoint security. Lastly, we're going to focus on understanding honeypots and the concepts that are used to detect honeypots. And then we're going to do countermeasures. So let's get started. Here in Objective 1, what we're going to do is summarize some of the basic concepts that we have for firewalls, IDSs, IPSs, etc. So let's start. First thing you want to look at is the idea of an IPS, an intrusion prevention system. What are we trying to do with an intrusion prevention system? That's right, prevent intrusions. But what it's doing is it's looking at data as it flows through. So let me show you where this data is coming from. So we have over here the internet. It looks kind of small on this diagram. We're going through the edge router in the organization, then through the firewall, and usually right behind the firewall, we'll have the IDS. What the IDS is going to be doing is asking some questions. It has a signature. Does the signature match the data that's flowing through in terms of looking like an attack? Does it match that? Is there a behavior that we see in this data that is anomalous? It's not like normal. Normally we do it this way and there's something else. There's something weird going on here. Or if we're looking at the TCP setup and the protocols that are going through, are they okay? Is there something weird about it? We do an analysis of it and find that out. And anytime there's a match, what's going to happen is we have an action rule. At the very least, what we're going to do is log it, but sometimes we could send an alarm. And if it's an IPS, we can take an action. And then at the end, if it passes all these tests, then we move into the enterprise network. Okay, so how does an IDS detect an intrusion? So I was talking about those three as we're looking at that diagram, but just to solidify the point, a signature is a collection of various types of actions, protocols, and methods that are downloaded periodically and updated on the IDS, where it can find things like misuse detection, it can find threats, it can find abuse, it can find network resource information. So what we want to do is have a signature that can recognize these things on the IDS. And then for anomalies, so in this case, what will happen is we have users, we have components of the network and computer systems, and what we're trying to do is see if there's any behavior that falls afoul of that. It's just different. And by the way, anomaly detection is the most difficult one of these to tune out of the box. Most IDS systems out of the box are 90% false positives, and then you have to tune them. And then for protocol anomalies, we're just trying to make sure that network traffic doesn't deviate from standards. So we have types of intrusion detection systems. One is NIDS, network-based intrusion detection systems. By the way, you also have network-based intrusion prevention systems too. If it's at the network, it's going to be at the edge, usually behind the firewall. It's going to be a black box that's placed there, and what it's doing is it's looking at all that traffic like we saw in that first diagram. The next one would be a host-based intrusion detection system, or HIDS. So there's also host-based intrusion prevention systems too, just FYI. and they sit on a host instead. So there's an agent running on this host analyzing what's happening on that host. And you might report those results out to an SMTP server. Either way, what we want to do is look for intrusions on that host and hopefully prevent them. What's going to happen with your intrusion prevention system, your intrusion detection system, is it's going to do alerts. What we want to focus on for alerts is true positive, and true negative. So true negative is down here. True positive is when your system says, alert, alert, you're being attacked, there's an issue. And surely enough, there's a horrible attack going on. What we don't want to happen is your system to say, hey, there's an attack happening, something's going wrong, and you look at it, and it's just somebody watching a YouTube video. You know what? That is not real. That's a false positive. So what we want to do is tune the intrusion detection system so that it will get true positives and true negatives. If it tells us that everything's fine and nothing's going on, nothing to see here, then we better not have an attack. All right, so let's talk about a firewall. For firewalls, I have this thing called Kevin's 4P firewall, 4P. So what a firewall in general does is it'll either allow or deny the 4 Ps. The 4 Ps are ports, protocols, programs, and IP addresses. I had to cheat on the last one. So ports, protocols, programs, and IP addresses. It looks at those 4 Ps and either allows them or denies them. You can create rules to make the firewall more effective. And so what it's going to do is stand at the network edge, stand between the private and public network. There are other places where you can use firewalls also. Let's talk a little bit more about that. One of them is the most popular firewall of all. In fact, right now, are you using a computer? You say, oh, you're not using a computer. Well, no, we're all using computers to be online and be on networks and use apps and so on. And on that computer is a firewall, whether it's a Mac, whether it's a Windows box, whether it's a Linux box, IP tables, you have a firewall available. And the thing about that firewall is it has a public interface going out to the internet and a private interface that goes to that box. Or are you at your house right now? Or maybe in a small business, and at the network edge, you have another bastion host, public interface and a private interface. Another type of firewall is a DMZ, which stands for demilitarized zone. It's really a screened subnet. So let me go grab a pencil, and we'll talk about what that means here. So let me crank this little guy on. And so a screened subnet is actually something like this. So here we have the internet. Looks like a cloud. Not too rainy. That's good. We have a WAN connection. And right over here, we'll put bricks in it. This is a bricks in a firewall, right? So we have a firewall. Then in the middle of the firewall, we have a web server. Web right there, right? And then we have another firewall. Let's put some bricks in that firewall. Those are very conveniently drawn bricks. I love that. And then over here, we have the interior network where you have your PCs and so on. So what we're trying to do here is we're trying to protect this internal network. So you have communication that goes through the internet, hits this firewall. This firewall has to have access. This device here has to have access to the internet. So we have ports open on this firewall. And if everything goes absolutely horribly and this web server gets completely taken over, then what we want is nobody can get past this firewall. Nobody can get there. Let me tell you why this is important. And a lot of you, if you haven't worked in companies that have data centers and so on, it may not be as understandable. But what happens is when you go into the data center in your organization, you're going to have these racks of servers. right there in your data center. So in this rack over here, you have servers that do, Active Directory and hypervisors on them and so on. And then you have just this line of servers. But in this rack, you have web servers. They're in your organization. They're right there. And so in this rack over here, we'll make it a different color. This is a COM rack, right? So this is for communications. And then you have, for instance, an edge network router that goes out to the internet over here. And we have a special port that takes it to that web server. But before it gets to that web server, guess what we're going to want to do? We're going to want to put it through that DMZ. So my point is, if they can crack that web server, it's possible they can hop over into your internal network. They're all in the same data center in this case. So it's very important that we isolate that web server. So for the exam, remember that a Bastion host only has two interfaces, public and private. For the exam, remember that what we want to put in a DMZ is a web server. Web servers go in DMZs. We also have the idea of a multi-homed firewall. And I want you to pay attention to this definition for the exam. Look, what does it say? A firewall with two or more interfaces. And the reason I say that, I've taught Cisco classes, Microsoft classes, CompTIA classes, and you name it, all kinds of classes. And often they'll have very interestingly conflicting definitions. So I don't remember which class this was, but the definition for a multi-home firewall was 3 interfaces. It didn't say or more. So if you're on an exam and there's a question that asks what a multi-home firewall, you better choose the one that says 3 interfaces, even though in reality that's the correct interpretation right there, 2 or more interfaces. So now we look at the types of firewalls, and the types of firewalls would be network-based firewalls, where they're looking at the network edge or at a subnet. Host-based firewalls, that's what you have on your Mac or on your Windows box. And then we have firewalls based upon mechanisms. They might be at layer 3 packet filtering. This is basically the 4P firewall I was talking about before. Circuit level gateway, they look at ports, more at layer 4 of the OSI, and they include layer 3. Application level firewall, where they're looking at layer 7 of the OSI model, looking at HTTP applications, etc. Stateful multi-layer inspection firewall, where they're going to go through every level and inspect those connections. Very important, all those important connections, they're going to inspect those. And then we have application proxies, and this is actually a really cool little tool. Often you'll find them at the edge of the network, and they stash information and they proxy the connection. That means that when you're connecting to the application, or web proxies, when you're connecting to the web, they do the connection. So you connect to them, and then they do the connection for you. And then we have VPNs, which is a nice little private encrypted tunnel out to the internet. Let's have a look here in learning objective number 2 at some IPS, IDS, and firewall solutions. Okay, so snort. Oh, I'm sorry. I was not asking you to make that noise. I'm talking about a tool here. And what this is a very nice open source IDS. It does packet analysis, traffic analysis, protocol analysis, content searching, content matching, all kinds of stuff. So Snort is really cool. Often you'll find Snort embedded in other tools, and you can use Snort from within those tools, and it'll write rules for you and so on. So Snort uses a rules language. For those of you who are Cisco people, or you deal with another vendor and you manage routers and firewalls, one of the things that you do is create ACLs. If you can create an ACL, you understand how an ACL works, then you'll be pretty good once you get used to the way Snort is set up. So let's look at some Snort rules. I'm going to go over here to this side. And you have these custom rules. You start with the type of alert. You give it the protocol for the rule. You have the source and destination. In this case, we're using the keyword any because it could be any source or destination. We have a directional operator that will be, from or to the direction it's going. You have an address for the rule, a port for the rule, and then you have your content for the rule. So not too difficult to create a snort rule. And in many cases, if you need a certain set of rules for a specific application, there are rule repositories. Like for instance, you can go to GitHub and find a rule repository. But we also are in the age of large language models, AIs, and so on. And so you can ask for snort rules. Like for instance, you can say, I'm setting up an application server that is running, and you describe the application, and I want to defend it from, and you give it a list of things you want to defend it from. And then so you tell it to write some snort rules. And you have to be a little bit specific, like, because you have to specify the direction the traffic's going and so on. And you'll pop out a bunch of snort rules that you can begin using. Another tool that I like quite a lot is Suricata. It's a nice little IDS, inline intrusion prevention, network security monitoring, and you can even take Wireshark. So with Wireshark, let's say that I'm monitoring. I set up Wireshark and I'm ingesting all these frames. And then what I can do is save all that information as a PCAP file. That PCAP file is easy to process in many different areas. So I can even take that PCAP file that I collected on Wireshark or somewhere else and process it on Suricata, looking for intrusion, signs of intrusion. Juniper, Samhain, OSEC, and Zeek, very good stuff. Cisco makes all kinds of good stuff, and they make a very good IPS. So that is intrusion detection. Intrusion prevention would be something like Trellix. They have a very good one. It helps you find botnets that are like sneaking around on your network, or maybe worms, or maybe somebody is reconnoitering your network, that reconnaissance. We also have Checkpoint Quantum, McAfee, and many others. You see Palo Alto. They've been around the security game for quite a long time. Over here, what we're looking at is firewalls. So let's go over to this section here. And so based on configuration, we have network on this side and host on this side. So Cisco Secure Firewall, or ASA. Have you ever used one of those? They're actually pretty cool. They have them for small businesses, and they have a nice little graphical user interface to help you secure them and configure them. They have them for large businesses, but these days, more likely you'll be using Cisco Firepower for that. And then we also have Palo Alto, Fortinet. A lot of my clients use Fortinet. They make a very good series of firewalls. And same with Checkpoint. A lot of my clients use Checkpoint. They make a very good series of firewalls. And then, of course, Juniper has been around for a while. And these are all at the network edge. All right, now let's move in to the host on the firewall. Microsoft Defender, the preeminent firewall of all time. I will say this, that Windows Defender, Microsoft Defender, has gotten better and better over time. They now actually will find pups and puas, potentially unwanted program, potentially unwanted application. They didn't used to do that before, so they're getting better. Zone Alarm makes a really good box. It's not really a box, it's an app. Komodo, I was talking about them before, that UK cybersecurity network protection company. Norton, have you ever heard of Norton and McAfee? Yeah, me either. What's that? No, obviously they make a very good firewall that runs on your desktop or on your server or on your laptop or whatever. And then we have based upon the mechanism. And so we have a variety of firewalls for different types of methodologies, for IP fire, pfSense, SonicWall. So all of these guys have different ways of interacting, and you can look them up. These are worth a look. And oh, one of these that I use a lot of, Zyxel, because my ISP always gives me these network edge devices, and half of the time I replace them with something I like better, but they've been getting better at making good network edge devices, so I kind of like that. We are in learning objective number 3. And here in learning objective 3, we're going to finally get into bypassing all of those firewalls, IDSs, and IPSs we were talking about in the previous learning objectives. So let's get hacking. There are a few techniques that we need to talk about. We need to talk. We really do. We start with firewalking and do all the way through tiny fragments up to IP address in place of URL, all the way through external systems and through bits. So we have 15 items to talk about. Let's talk about the first one. All right, so if we look at what we're doing here, what we're trying to do first of all is find out what it is that we're dealing with. So this first one, we're going to banner grab the firewall itself. So for instance, manage engine, that firewall listens on UDP ports 514 and 1514. So if I find out those ports are open, I'm like, oh, hey, I've got a manage engine firewall. And snort listens on 80 and 53. So I might find I have a snort IDS in front of that system. So I want to banner grab that, find that out. Another thing I can do is use a little bit of packet crafting or a tool that does this, like Nmap, and do some firewalking. And no, you don't have to walk on any hot coals. Don't recommend it. But in this case, what we do is we alter the TTL value to make it one more greater than the targeted firewall. So it expires right after the firewall. What are we trying to do in this case? What we're trying to do is find the ACL filters. So we're determining the access control list on this device. So first of all, we do a identification through port scanning of the device. Then we find the rules of the device. And then over here, we get some more banner grab. We fingerprint it. Maybe we can get versions, information about install location, stuff like that. Looking at service announcements, trying to get information on this firewall, on this device. Okay, so now that we have some idea of what the device does, what we're going to do is we're going to do a little bit of work on it. Let's have a look. All right, so if you look at this slide here, what we're going to start off with is IP address spoofing. And so what it does is we're going to alter the source IP address of the packet header to conceal our identity as the attacker. And what it does is it makes it appear like that packet came from somewhere else. And we can use this to gain unauthorized access to systems. One of the examples I was using a little bit earlier is of a firewall that has a rule that says if your IP address is 2.2.2.2, hey, then you can access the network. And so one of the tools we can use for IP address spoofing is hping. Hping is a very nice little tool for that, very easy to handle. The next one we've already been talking about already, just a little bit, is called source routing. And so what we do is we can send a packet and designate which route that it should take on the network. And so what we want is to choose a less secure alternative segment to get there. And we do that by influencing that network path. And let's look at tiny fragments, little teeny fragments. So what we do is we create these tiny fragments of outgoing packets. What we do with that is we cause some header information to spill into the next fragment. What this does is it can break up the packet headers, making it harder for the IDS, the intrusion detection system, to analyze. And what we're doing in this case is we're exploiting the behavior of how routers filter in order to get beyond that network edge and bypass security checks. All right, so let's have a look at this one. In this case, we are, that you can be outside or inside. In fact, if you look at this diagram here, the attacker, what's he doing? So he is using an IP address instead of the FQDN to get to Facebook. You know where this really would happen more likely is it's not some attacker from outside the network, because Facebook, I mean, that's an entire company. We're just trying to get a page. You know, this could be you. You get a new job at a company, and you try to go to Facebook.com and it doesn't work. And all of a sudden you start to get the shakes. You thought you could quit it whenever you want, but you need your daily fix of Facebook. So what you do is you do a service like host to IP, and you discover all the IP addresses that Facebook has listed. And you might try the first one, and that's blocked. You try the second one, that's blocked. And finally, when you get to your 16th IP address, it's one of the latest ones, it hasn't made their block list. And sure enough, Facebook comes up, and you breathe a sigh of relief and start looking at what your cousin is doing. Other things that you can do, again, I'm looking at this from inside the network, trying to get out of the firewall from inside the network. And so what you can do is use anonymous access. There are all these anonymizers online, like anonymize.com and 2ip.io, Anonym, and many other things. And what it does is hides the actual IP address. So if I am going to a site that's blocked by my company, and I use one of these anonymizers, then they won't even see the IP address, and maybe they won't block it. Oh, but I will say this about a lot of the stuff we're talking about in this area. Anonymizers, for instance, it's very likely that another thing that the organization blocks is anonymizers. So it may not work, but like I said, a lot of this stuff doesn't work. We have to keep trying things over and over. Another one would be to bypass the IDS or the firewall using a proxy server. And so what you can do is do a lookup on proxy services online, and you might find a cloud proxy service. And then what you do is you go to your LAN settings, and then in your LAN settings, you put in the IP address of the proxy server. And once you put the IP address of the proxy server in, then everything you do goes through that proxy server. Yes, your organization is likely to block proxy servers too. So what you can do is create your own proxy server in the cloud, or maybe even from your home network or something like that. But you know what else an organization is likely to block for users? Is the ability to change LAN settings. So again, this might be problematic to work. All right, so another thing that I might want to do is get information in and out of the network. So if I'm an attacker and I have found some information and I want to exfiltrate that information, or if I'm a user and there is information that I want to exchange or make use of, I need to be able to get past that IDS or that firewall. And what better protocol to get past it but ICMP. ICMP is allowed in a fair amount of networks. So I can use a tool like ICMP-TX and then take all the payload information that I'm moving in and out of that network through that firewall and just make it look like normal ICMP traffic. Also, I can do the same thing with ACK tunneling. With ACK tunneling, I can bypass the IDS or the firewall because it's just an ACK flag on a TCP segment. That's all it is. It's got to be legitimate, right? Looks like a normal connection. So I can use HPing or NPing, for instance, and get past the firewall by varying the ACK flag. Another one is through HTTP tunneling. And so what I can use is a tool to take my communication and make it look like normal HTTP traffic. And so if you want to do that, let's kind of zoom in on these steps. So what we want to do is make our traffic look like it's just plain old HTTP, no matter what it is. So the first thing you want to do is disable IIS admin services and World Wide Web publishing service. If it's a workstation, it's likely that's not running anyway. The next thing we want to do is run HTT host with its default settings. You're going to put together a password, check, revalidate, DNS names, log connections. Next, you're going to verify your listener. You're going to enable Defender rules. You're going to run HTTP port. That's the other side of this. So you have host and port. You go to the proxy tab, enter the IP address, port 90, and the password. And then you go to the port mapping tab. Either way, you set this up. When you do that, kind of looks like this. This is HTTP host, and this is HTTP port. And then when we do that, we should be able to get past the firewall if it allows HTTP. So in this case, what they're doing is they're contacting an FTP server. All right, what about SSH tunneling? What do we do to get past the firewall? Well, one thing is we can encrypt the information. So we encrypt all the traffic. So this is a very nice little tool. I say little, but it's actually huge. It's OpenSSH. We can create and encrypt a tunnel. It's just giving you an example of a command that you can use and encrypt the traffic and get to other things where you want to go. The next one is some of the tools and techniques that we can use for SSH tunneling. So just like with other encrypted protocols, SSH tunneling is actually pretty cool. What we can do to make that work is we can use local port forwarding. And so what we do is we try to get to internal resources that aren't directly accessible. I think we looked at this in one of the earlier modules where we did port forwarding. A remote port forwarding, you can gain access to local stuff by doing that port forwarding. And by the way, both of these are going to require some access to one of the boxes in that network. And then dynamic port forwarding, you can essentially create what's called a SOCKS proxy through an SSH tunnel and then route any traffic and access it, whatever services you want. And since it's encrypted, you won't be detected. So if you look over here, one of the very cool tools that makes this possible is called Bitvice. And we're going to practice a little bit of that in the upcoming lab. All right, what about DNS? DNS is, I would say that it's much more accepted than ICMP for sure. And so what we can do is do a DNS tunnel. There's a fortunate thing for the attacker about DNS. And so it's UDP. It has a 255 byte limit on outbound queries. And so that is a nice little size constraint that we can use. And so we can set up external queries and use that information to shove data into that 255 byte limit and eventually communicate inside and outside, maybe gain access to a command and control server, move data, etc. So there's a nice little tool over here called Iodine that does a very good job of that. And there's another one called a DNS Cat2 that you can use for that purpose. All right, another thing that you might want to do is access the firewall through external systems. So when we're talking about external systems, let's just kind of have a look at what's going on here with external systems. So this is just a method that we're using to, again, bypass IDS or firewall by exploiting external systems. And what we have on the outside is a legitimate user. And so we have this legitimate user that has access to this back-end corporate system, but this legitimate user is external. So maybe this user is at McDonald's or at the public library or somewhere else. The attacker over here is sniffing traffic, intercepting information, like for instance, capturing the session ID and cookies of this user. So over here in the network access segment, they're using the captured information, the attackers using the captured information and bypassing this firewall, IDS, etc., to gain access to the corporate network. So now they're on the corporate network. And then we have the idea of command execution. So with command execution, they can issue a function called OpenURL, and they do that to on the whatever Mozilla process that they've identified. And then from there, I think that's number 5, somewhere around there, what we do is the browser of the user can be redirected over here to the attacker's malicious server. And then from there, arbitrary code execution. So malicious code on the attacker server is downloaded and executed on that machine. And so what this does is it allows the attacker to exfiltrate information that should be secure from that corporate network. So let me ask you a question. Why? That's the question I have for you. Why was this possible? Look at this diagram. What is missing that allowed this to happen? We have a firewall. We have you know what? Encryption, right? It's encryption. This is not encrypted. And this is why in the very beginning, the attacker was able to sniff this transaction and then take advantage of it and eventually steal the data. All right, let's have a look at this one. So in this one, what we're doing is we are bypassing the firewall through an MITM attack, man in the middle. And so what we're doing here is the first step right here, something we talked about in a previous lab, module, which is DNS server poisoning. So what the attacker is going to do is poison the DNS server. So they're going to corrupt that DNS server's cache, put their own information in there. It's incorrect. It's got the wrong IP addresses that will be returned when there's a query for a name, like a domain name or fully qualified domain name. All right, the second thing that's going to happen is the user A in this case, is going to send a request. In this case, they're sending a request to www.certifiedhacker.com, but they're using the corporate DNS server. That's what they're trying to do. So the corporate DNS is going to respond, supposedly, it's supposed to, but instead of setting the correct IP address, the compromised DNS server sends the IP address of the attacker server. So if you look down here, we have the malicious server, this one right here actually, which is 127.22.16.64. By the way, this 127, this is actually a loopback address. You know how you think 127.0.0.1 is the loopback address, but actually the entire address space of 127 is loopback. So anyway, fake address, which is good. And then we go to the step number 4. We get access to the malicious server. User A now accidentally, here we go, connects to this malicious server instead of going to the legitimate website. And then in step number 5, right over here, where we have certified server, and then we have the malicious server. So in step number 5, that's when we're tunneling HTTP traffic. So the attacker is going to act as an intermediary connecting to the real website, which is that certified hacker website. But they're tunneling user A's HTTP traffic through their malicious server. And now the attacker, if you look at step number 6 over here, the attacker's server can serve up a web page that has all that malicious code in it, which is downloaded right over here and executed on user A's machine. So the attack allows the attacker to intercept and manipulate the communication between user A and the legit website. And because of the arbitrary nature of the code that can be run, this type of thing can be a pretty serious breach. But let me ask you to analyze this. I want you to do some forensics on this. What is missing on this slide? What do you think? Well, let's see. We have good servers. We have good communication protocols. We even have a DM. Yes, you got it. Encryption is missing on this slide. Okay, so the next thing we want to do is bypass through content. So let's have a look here and talk about what we mean by bypassing through content. Well, this is something that we've actually been talking about quite a lot, and this is the content of for instance, a web page or some other type of communication. So we send the content that has the malicious code in it, and we trick them into clicking the link. It sneaks through because the content is allowed. The web page, the web app is allowed. And so this is like, for instance, it could be a Microsoft Office document. We're going to talk about that a little bit later in this one, a bypass exploit, or it could be a corrupt PDF document, or it could be some other type of content. All right, this one is an introduction to a type of attack that we're going to spend a lot of time in this class talking about. And the first one is cross-site scripting. So we're talking about cross-site scripting in general, and we're trying to get back past a web application firewall. And so one of the things we can do is we convert the command that should not be allowed, because it says script, right? It's a script tag. Or actually, this is the scripting information in between the script tags. Convert it to ASCII, and it just looks like a series of numbers, and it may not match a signature. Or encode it in hex, and it just looks like a series of numbers and percents, and it may not match a signature. Or obfuscate it by doing upper and lowercase, and it may not match a signature. Also, to bypass that web application firewall, we can use HTTP header spoofing. And what we're doing here is we are messing with the X-forwarded for, tricking that into believing that the request came from inside the network. We can use blacklist detection. What we want to do is find what types of keywords are blacklisted, and then we can create a little regex. These are regular expressions that help find things, and make sure that we don't have those keywords in our hack. And then down here, we can use fuzzing or brute forcing. We've already talked a little about that. We can even use word lists with usernames and passwords. And then we can abuse SSL TLS. There are many different ways of doing that, but we have a couple of tools. This is called SSL Scan 2. Nice little tool. There's another one called Abuse SSL Bypass WAF. This has been around for a while. It can be fairly effective on systems that are not defended. Right, there's another type of exploit that can be very interesting, and this is known as HTML smuggling. So let's have a look at HTML smuggling. With HTML smuggling, this is yet another method to bypass an IDS or a firewall. So let's kind of zoom in on this slide and talk about what's happening here. So what we do is we're bypassing the IDS, and what we're doing is we're smuggling a malicious code. So it could be HTML, it could be JavaScript to compromise a web page. And what we're trying to also do is keep that attacker hidden from the firewall, from a web proxy, from an email gateway. So let's have a look at what's going on here. The first one we see is the attacker is going to initiate the attack by embedding malware using HTML5. It's an HTML5 attachment. So over here we see that href right there. And so we have an HTML anchor. That's a little A anchor, that little A tag, to create a link that's going to trigger the download of that malicious file when it's clicked. So the href attribute actually points to the malicious document, and the download attribute right over here is going to specify the name of the file when it is downloaded. So we look over here at this next one, and we're doing HTML smuggling using JavaScript. And so we have a little var here, my anchor element equal document.create. So that line right there, what it does is it creates a new anchor element. And again, that's the A that we're looking at, and sets it to trigger the download of a file over here named mydoc. And we use that to create a download link, but we're doing it programmatically. And then the last one here is where we are using my file URL equals. So what it is a Java snippet that creates a URL for a blob object. What is a blob? binary large object. And this is going to contain the malicious content. And it assigns it to the href attribute. And then once it does that, it programmatically, someone clicks the link and they'll start the download. So the code uses JavaScript's blob content to hide the malicious content, which it makes it harder for a security system to detect, and allows the attacker, in this case, to connect with the malicious server. And what they do is they just show you how an attacker can use up here HTML5, and then down here JavaScript to carry out pretty sophisticated attacks and evade firewalls. All right, the next thing we look at then is some of the tools that we can use to do this. This one is BITS. BITS has been around for a while. It's used for a Microsoft update. It's called the Background Intelligent Transfer Service. And this allows us to take advantage of this to launch malicious code, malicious applications by making use of API function calls. All right, so there are many other techniques for IDS evasion: insertion, evasion, denial of service, obfuscation, false positive generation, and many others. I would encourage you to look at your courseware or look some of these up online. They're actually very cool. The only issue is you need to have a tool to do each one of these. We're going to talk about some of the tools that get some of this stuff done a little bit later in the module. All right, so we are now in objective number 4. And here in objective number 4, we're going to get into a little bit more technical section talking about different techniques to bypass. In this case, we're looking at NAC, and we're looking at endpoint security. So with NAC, what we're trying to do is not allow certain devices onto the network. We're protecting the network from those devices. And for endpoint protection, that is stuff like McAfee or Norton or whatever you're using to monitor and manage those endpoints. So we're going to be looking at some of the background of what goes on with these types of devices and connections, and how we can bypass the safeguards on those devices and connections. So let's get started. All right, the first thing we want to look at with bypassing NAC and NAP and endpoint protection is the list of techniques that we're going to talk about. Let's have a look. So if you look over here, we start with VLAN hopping. We already mentioned this earlier, but there are other ways of doing it that we're going to look at. We're going to move through using pre-authenticated devices. We're going to look at ghost writing. We're going to look at writing doing application whitelisting, dechaining macros, creating clearing memory hooks, process injection, LOL bins, and many others. I think I'm not going to go through each one of these. You can always pause and read through each one of them. But you know what? We're going to go through all of them anyway. So let's start with a look at VLAN hopping. So with VLAN hopping, what we're trying to do is get around this pesky little VLAN that I'm assigned to and I can't get out of. I already talked to you about DTP in one of the earlier modules, Dynamic Trunking Protocol, and how ports can have different modes that they have. The two major modes that can cause it to turn into a trunk line is dynamic auto and dynamic desirable. And so there's a tool called VLAN pwn. Pwn is, as you know, hacker talk for own. You own that VLAN. It's a little Python tool. We do double tagging .py, and we give it the interface we want, and we can double tag that VLAN. So that is one way to VLAN hop. We were looking at other techniques like using port. We could do port hopping with forged gratuitous ARP, and there are other ways to get around. We actually did talk about VLAN hopping. But I want to talk to you a little about NAC. So with NAC, we have the idea of network access control. What network access control is all about is making sure that, let's say that I come in after hours and I bring my cousin Sally with me to the office. And Sally has a laptop and she breaks out a cable and plugs it into my unprotected ports. And now she's on the network. Little did we know, but there was a worm on Sally's computer. And now that worm travels all over the network. What can I do to make sure that devices that shouldn't be on the network aren't on the network? There are two ways of doing this. One is NAC, which is Network Access Control, that we're going to be talking about. And the other one is NAP, or Network Access Protection. Network Access Protection is really something that's kind of pioneered by Microsoft. And what it does is it has a remediation server that, for instance, if you don't have updated patches or antivirus, it'll remediate that box and then check it to make sure it's okay before it allows it on. Network Access Control is a little bit tighter, and what it's going to do is stop devices that don't have appropriate authentication from being on the network. So let's kind of zoom in on here and talk a little bit about how we can get around NAC with a pre-authenticated device. So what we want to do is we want to first have an access device that is already authenticated in the network. And then what we do is we do what's called smuggling network packages. So what we do is we use that device to log into the network, and then you smuggle a network package from another device through the connection. So this connection, this authenticated connection. And then what we do next is we poison the attack device. So we put a secondary device, and they mention in this bullet point Raspberry. Raspberries are so useful for many things, but you put the second device between the pre-authenticated device and the authentication server, and what happens is now we flow through the Raspberry or the secondary device, and there are tools that you can use like Fenrir and others to bypass NAC. So that's one of the things we can do is bypass NAC. There's another tool that we have called ghost writing. What in the world is ghost writing? Well, let's have a look at this slide and zoom in a little bit on it. What we have with ghost writing is a way to modify the structure of code, the malware that was written. But what we do is we maintain the functionality of it. So what we do is deconstruct and reconstruct the binary. And then what we do is able to take that and bypass the signature. So it doesn't quite match the signature. One of the tools for that is ghostwriting.sh. Over here on the right side is application whitelisting. And so with application whitelisting, what we're going to do is bypass whitelisted apps. So let's talk a little bit about that. Let's go over to the board here. And with application whitelisting, I have a device and only certain applications can run on it. How is that determined? Well, there are DLLs that help work with that. So as an attacker, I do some DLL hijacking and I put a malicious DLL into place. But wait a minute, how do I get that DLL into RAM? There is a really cool tool that can help with that. It's called regserve32. Let me back up a little bit and take you into the past and talk a little bit about how I have used regserve32 in the past. So I've been a network administrator, network engineer many times, both contract and working for companies. And several times in the past, there's an organization that has a giant client server application. So it's running, there are users using it. You can't bring it down, but there's a functionality issue or a security issue with the client server application. So you can't just bring it down and fix it and then bring it back up, because it has to be running 368 days a year. And so what you do is you get the DLL or set of DLLs that the organization that made the code gives you, and you use regserve32. What regserve32 does is it takes that DLL and shoves it into working memory, replacing the current DLL or adding it to the list of linked libraries that the app has access to. So that's what we're doing here. We're using Redshift32 to take that malicious DLL and get it running. Now that it's running, the app that I want to start or use or whatever, it's whitelisted. So that's application whitelisting. All right, so let's look at some other techniques. We're going to look at spawning through shellcom, and we're going to also look at XLM-DOM. Let's have a look over here. So on the left-hand side of this slide, we see that we're using shellcom, and on the right, we're using XML. That should be, XML DOM. So with shellcom, what we're doing is we are going to reference any object that's associated with COM. COM programmatically is the component object model through VB script, and then exploit its function. So if you look over here, we have a VB script. We have a set object and a new, and see that number with the C, 08, etc., ending way over here in 880. So this creates an instance of the object. And then we go down here, we have ob.document .shall execute. And what do we see here? What does that look like? That's the calculator, calc.exe. And then we go to null, we see system32 null. What we're doing is we're making this command execute the calculator application by using the COM object to interact with the system shell. So we're able to spawn through shellcom. And then another one is XML DOM. And what we're doing with this one is we're spawning a process through XML DOM. What is XML DOM? That's the XML document object model. And it allows the attacker to run code. And if you see here, we're using the office process. And so let's look at the code here. We have set XML create obj, and we have Microsoft XML DOM. So the next one is XML async equal false, set XML XSL equal XML. So what we're doing here is we're loading a malicious XSL file from a specific URL. Then you go down here to the node XSL. We're going to execute the transformation using a malicious XSL, and this could be harmful code that you use. And there are other techniques that we're going to look at, and one of them is actually very interesting. Again, these are low-level techniques that we use to stop the processing that would normally not allow certain actions. We want to get around that. So if we look over here, what we're doing is we are clearing memory hooks. What is a memory hook? Well, we have what's called EDR. EDR is endpoint detection and response. It's an agent that's going to run on that system to monitor and analyze everything happening on that system, to look for actions, applications, methods that aren't allowed, and analyze the behavior of applications. So these hooks are intercept specific system calls, and that's why over here we see syscalls and function calls that allow this EDR to collect data on potentially hacker-like activities. So the attacker is going to try to bypass these hooks. We see a little, this is a debugger that we have up and running, and they want to bypass the hooks. And if we can bypass the hooks, then we can avoid detection by unhooking those DLLs that are responsible for making this EDR work. And what we want to do is restore the original function codes. So we have EDR, DLLs. These are dynamic link libraries like we were talking about before. They're injected into processes by the EDR to replace hooks of crucial functions and syscalls. So what are we going to hook? We're going to hook stuff like ntdll.dll, stuff like that. So what the EDR can do is monitor system level activities. So that's why we target these DLLs to disable them to allow us to do those hacker-like activities. Well, let's look at the right side of the slide. And for the right side of the slide, you see that we are looking at syscalls. And when you look at syscalls, these are system calls, the interface between the user application and the kernel, the operating system. And so what we're going to do is monitor syscalls and find out where the hooks are. We're going to identify those hooks, create our payloads, restore the original function, and eventually hack this system, or allow the code to run that we've created for that system, allow our payload to run. The next thing we look at then is yet another way to bypass some of these protective processes that we have running on the system. So let's zoom in on this slide here. And what we see is we're doing process injection. And so this is actually a more sophisticated technique that an attacker might use to inject malicious code. What we want to do is bypass endpoint security. This can bypass IDSs, firewalls, antivirus software. And so what we want to do for process injection is stealthily inject malicious code into memory space. We're looking at a running process. And so you can execute your code under the guise of a legitimate process, making it a lot more difficult for your security to find it. The way it works, so let's have a look at how it works. So we have some specific APIs that we're using. One is a virtual alloc, X. And this function is used by an attacker to allocate memory within the address space of the target process. And so that allocated space will eventually be available, see that little syringe there, to hold that malicious payload. The next one is write process memory. So after allocating memory, we use the write process memory function to write the malicious code and it into the allocated space. That's what we're doing, shoving it into the allocated space. And then we have this one down here, create a remote thread. And so this one creates a new thread in the target process that executes the code. So memory allocation, write the code, and then execute it. And what happens when you do this is when you inject this malicious code into a legitimate process, you can do things like maintain persistence, you can escalate privileges, and do other types of activities like that. All right, the next one that we're going to be looking at is LOL bins. And no, we're not laughing out loud. LOL bins are living off the land. So let's zoom in on this slide here and look and see what we're going to do. And what are we doing with this one? Again, we're bypassing EDR, or endpoint detection and response. We're using living off the land binaries. So a binary, of course, is like an executable. And it's a legitimate tool. LOL bins are legitimate tools. They come pre-installed on operating systems. You can download them from trusted sources, like for instance from Microsoft. And so what some of the steps are involved is, number one, we're going to configure the agent. So this one here is called the Demos C2. So we have to configure that agent. And number two, we're going to run the command. And what we want to do is use a legitimate Windows binary. In this case, we're using config-security-policy.exe to download a remote file from a specific URL. And then number three, we're going to run custom shell host exe. And so the attacker can use privileges on a Windows 10 or 11 box and execute that custom shell host exe and trigger other malicious actions from there. So that's another thing that can happen. Let's have a look at this guy over here, and that is a CPL sideloading. And so with CPL, the CPL is the control panel. And what happens is sideloading, it's going to mimic the original CPL app functionality and make it look legitimate, but allow the attacker to execute code that should not be able to run because we sideload it as a CPL object. And so over here we see CPL files. Each one of these has a .cpl in the end. And in this case, what we do is we have code here for creating a functional CPL file format, and then we can use that to run that in System32 and make a new object that will run under control panel and bypass a lot of protections on the system. Well, we also have the ability to make use of large language models and generative AI, by the way, for attacks and bypassing security. So in this case, what I'm going to do is I'm going to use ChatGPT to mutate malicious code and create multiple versions of it. So the first thing we want to do is get the code. Do you know that there are repositories of malicious code? So one of the things that I tell my employees that are in IH&R and they're in forensics and my students is that you can, for instance, go to GitHub and there are these like virus and worm libraries. They have thousands of viruses. These are all well known. And if you run them on your system, your antivirus will catch them all. But what I like to do is make sure people are trained on how to mitigate attacks. So let's say I take one of those viruses in, or a worm. Worms are really cool. I get a worm from a repository. I get that version, and it could be ransomware or whatever. In this case, it's a worm. And then what I say is, please write for me a function named find these files in Python that searches all the files that end with text, PDF, PPT, and it gives all the like basic files that you'll find in a documents folder, right? Starting from the root directory, returns a list of all paths of all the files that match the criteria, include relevant imports. Only provide the code without explanation. So boom, it gives you code that you can run to go find stuff on a system. Please make for me a function encrypt given file that receives an encryption key and path to the file and encrypts it in Python. Include the relevant imports. Only provide the code. Boom! There is the code. So what we did is we used ChatGPT to mutate. In this case, we didn't mutate code. We actually created code. And if you prompt the LLM correctly, you can get quite a lot of good code out of it. So you can mutate code. I can take like for instance, let's say I go to a code library and I get the code for a worm and I dump it into an LLM and I say, rewrite this code so it's more efficient. So now it doesn't look like the original worm code. And then when I compile it, it is not something that will be able to trigger a signature. Or let's say I get a worm, it's written in C, and I say rewrite this in Python, and then make it more efficient or something like that. So we have different ways of mutating code. We have ways of writing code also. Metasploit is also very good to use to help mutate code. We're just talking about that before. So let's say that that worm I was talking about that we got from a repository, and I want to infect a system that I'm targeting, and I get that worm and I drop it into VirusTotal. Oh my goodness, I scored a 60. Everybody knows about this worm. Okay, let's see if I can modify it. So I drop into MSF Venom, and there are some templates that I can use to scramble the code just a little bit. And then we output it again, and we drop it into VirusTotal, and it's 43. Hey, that's nice. Well, let's run it through again. Maybe I can make it 32. Maybe I can get that score low enough so that the antivirus that's on this network won't trigger when I run that code. We also have the AMSI. AMSI is the Windows anti-malware scan interface. Microsoft has created an entire API, an entire interface to work with anti-malware. So if you're running Norton or Avast or whatever, there's an API that you can use in the back end to make sure that you have a good scan of the Microsoft environment. Let's have a look at what we're doing with this. So we have various techniques, as you can see here: PowerShell downgrade, obfuscation, forcing an error, memory hijacking. These are various techniques that we can use to bypass that entire interface, the AMSI. And that's, having that interface is nice, but if we can get beyond it, we will be able to run an attack. So if you look over here on the downgrade, what we do in this case, and it's hard to see right here what you're doing, but what you're doing is you are downgrading PowerShell to version 2. Version 2 is hackable, much less secure. It lacks AMSI integration, and therefore we can attack. Another one would be obfuscation. So in this case, what I do is we have code that is obfuscated, and it makes it more difficult to read. And by the way, you can use LLMs to help with this and evade the signature. I was just talking about that in the previous slide. Another one would be forcing an error. So you create code that you create in order to manipulate, generate errors, and the error that it generates is one that will disable the AMSI checks. And then down here, memory hijacking. With memory hijacking, we're going to manipulate the memory process where AMSI is, and it allows you as an attacker to load a malicious code without being detected. And these are actually fairly sophisticated attacks. These are some basic versions of those attacks, but these also can help you bypass endpoint protection. All right, the next one we look at then is some other techniques for bypassing endpoint security. You can host a phishing site so that you can get people to that site. And since your EDR is going to be using blacklisted IP addresses, and they're going to be regularly updated, you have a cloud resource with a new IP address. It is not blacklisted. And so therefore, we can bypass endpoint security. Passing encoded commands. And so what we can do is hex encode the commands, fast flux DNS. We're changing DNS so often that it doesn't know that that DNS is actually leading to a command and control. Timing-based evasion. This one, what we're doing is we have malware sweeps that are executed at certain times. And so we use things like sleep patching or delay APIs or time bombs to take advantage of the timings that happen on that workstation. Signed binary proxy execution. And so we have these built-in utilities. We're talking about redserve32. One that works very interestingly for DLLs is rundll32. And what we try to do is evade EDR by using trusted DLLs, trusted binaries, the ones that already have digital certificates. So we can actually use those built-in tools kind of living off the land. All right, so we have a few more here. So let's zoom in on this one here and have a look at a few other techniques. One is called shellcode encryption. So anytime you can encrypt what you're doing, it makes it very difficult for the endpoint protection, for the EDR, to be able to understand what's going on. So what you do is you take your malicious payload and you encrypt it. The next one we see over here is reducing entropy. Reducing entropy. So what you want to do is look at the characteristics of your binary and just make it less suspicious. That's what we were doing before when we were referring to a virus total. And so you can kind of blend that malicious content with benign content, maybe entropy images that you blend into the binary in order to disguise what it really does. You can escape the AV sandbox. So we have this environment. And so what you can do is that sandbox is going to stop you from doing quite a lot. We'll see this when we're doing mobile. But what we can do is calculate, for instance, large prime numbers and use those numbers as a key to extend the encryption process. And what we're doing in this case is we are bypassing the sandbox time limits. So the next one we look at then is disabling event tracing for Windows. And there's a little ntdll.dll, which is a pretty critical DLL. And so what we want to do is patch that DLL. And so we patch the event view write function to return a success code and silence it. The next one after that is spoofing the thread call stack. And when we do that, what we're going to do is modify the return address of a thread that's in its dormant state to point to the shell code. And then that return address is overwritten with 0. That 0x means it's hexadecimal. And then the sleep function is called. And when you call that sleep function after doing this, you can stay undetected. And then the last one we look at in this section is in-memory encryption beacon. And so what they're going to do is encrypt the executable memory regions of the malware that the attackers created, which is called the beacon, while it's in its dormant state. And then they can do that by finding the hooking functions, like the sleep function in the target system, and make sure the beacon stays undetected. Okay, so now we are in objective number 5. And what we're going to do in objective number 5 is identify honeypots. So let's get into it. So for honeypots are actually really nice, because with a honeypot, what you do is there are various types of them. And the purpose is to look like a real network, look like a real application, look like something that the attacker just might want to hack. And so what will happen then is the attacker goes to the internet and they end up in a honeypot. This honeypot looks like it has a web server in it, looks like it has all kinds of stuff in it. And when the attackers in the honeypot, we can log everything they do. We could log every keystroke they make. And we know that there's an attacker in there. It flags it. We have a warning. And now we can characterize that attacker. We've trapped them. We've set them up. And they're in the honeypot. So if you are an attacker, one of the most important things to be able to do is to identify a honeypot. So in order to do that, let's talk about the different types of honeypots. So some of the classifications / categories of honeypots are low interaction honeypots. They're very limited. So usually you're not going to use those for the real world. Medium interaction, they simulate operating systems a little bit better. A high interaction, all services that you might find in a larger network. So yeah, definitely you want a high interaction honeypot. A pure honeypot. These look like a real production network. And so we have production honeypots and research honeypots. These are better in some cases than pure honeypots. We also have honeypots for specific purposes, like spam email, networks, and databases, and so on. So we have highly specialized honeypots. So there are a variety of interaction levels that you can have with honeypots, a variety of types of honeypots. Some tools that you can use, this one is Honeybot. It's a nice little honeypot. It's ideal for network security research. So you're not going to really use this in a corporate production network, but it's one that you can practice with, maybe using for a smaller organization. And there are some others like by Bulimria and by NeoSwarm and Valhalla. So there are many different honeypot tools out there. So if you are running the hack, let's say you're on the red team in your organization, or you're doing a black box pen test, you want to be able to detect the honeypot. So what are some things that you can do in order to do that? Number one, fingerprint the service. So what we have here is the nmap command with -SV for a service. We're looking at the service in port 80 and the target IP address. And so what we're looking for is discrepancies between what is claimed and what is actual. In fact, we'll see that that idea of discrepancies is what we're looking for throughout most of our testing. So I'm going to test that and see what that service really is. Next thing we're going to do is analyze response time. So what happens in a real network is you're going to get dynamic responses. So for instance, every time I send a packet across, let's say it's a campus area network or a corporate network, because of the vicissitudes, the changes, the dynamic nature, I'm going to get different response times going to that resource and back. So I want to look at that latency and measure it. So we can use ping, traceroute. In this case, we're using Nmap with a scan delay of 1 second with a max retry. And so what we're going to do is look at each response time over time with this Nmap command and look for variances and variability. The next one is we want to analyze the MAC addresses for irregularity. So we can use ARP scan and look on that network. What we want to see is, are we getting real MAC addresses? What if you scan the network and all of the workstations are VMware? Interesting. Well, maybe they're all virtualized. Okay, all the servers are VMware. Oh, that's interesting. All the routers are VMware. All the phones are VMware. Everything's VMware. It's the printers. A VMware printer? Really? Do we need a VMware printer? What you found is a fake network that's running off of VMware. You can tell by the MAC addresses that VMware creates. Enumerating unexpected open ports. So what we're going to do then is do an Nmap. This is actually a cool Nmap command, -b-. This means scan all 65,535 ports, every single port that's possible, scan them all. Be aware, however, that that's going to take a little bit of time. And be aware also that if you use a network range here, it's hardly ever going to finish on a large network. So be careful with that. Also, if you are on a test network or you're on a virtual network, then you might want to use a -T5 on this command. But if you're on a production network, then be very careful with this command. All right, the next one we look at is analyzing system configuration and metadata. And so what we're going to do is look for banners, look for settings, look for metadata tags, look for default configurations, discrepancies in what the system says and what it really is. So we're trying to find our way through this network, looking at the apps, looking at the workstations and servers, even going to wireless access points and looking at the way they beacon. Are they really connecting to supplicants? These are devices that connect to the wireless access point, or is it all fake? Okay, so yes, you sent a couple of employees to take the Certified Ethical Hacker class. Now you have to defend your network from them. Maybe it's you, maybe it's me taking a class, right? So normally though, we're going to defend our network from outside threat actors. But either way, if it's from a CEH student, don't do it. Don't attack your network. Or it's from an outside threat actor. We need to be able to take countermeasures to defend ourselves from people who are evading our IDSs and firewalls. All right, so what are some of the things that we can do? A lot of them are the converse of the action that we took to bypass the device. So for instance, we were looking at attacking a switch. So we shut down the ports. So if I have a friend who comes with me into the office and she brings her laptop, she should not be able to plug into a port. It should be closed. Make sure you analyze your traffic, analyze your TCP connections, making sure that you look for the no op code other than 0x90. So what are we doing with that? Well, that is a sign that there is a polymorphic shellcode problem. So we want to identify that. Train users to identify patterns, deploy IDSs, IPSs, firewalls, configure the IDSs, IPSs, and firewalls. Use a traffic normalizer. What a traffic normalizer is a tool that looks at every single connection, and if anything falls outside of a specific set of norms, it drops it, doesn't allow it through. So normalize fragments, make sure every fragment can be reassembled. Define your DNS server for client resolver in routers or similar network devices. In other words, we want to set up and protect our DNS servers both at the client and at the server level. Harden our security. Be careful with that TTL and when they're expired. So we can have, if we have a ICMP TTL and it's expired, block it. Update your antivirus. Traffic normalization. We already talked about normalization a little bit before. Store attack information. So in other words, what we want to do is say we have a honeypot. There's an attacker. We're watching them. We see their IP address. We see any DNS information, FQDNs that they use. We want to get the TTPs and the IOCs of that attacker and make sure you have them stored somewhere. Other things that you can do for firewall evasion: filter your IP addresses. So you want to make sure that an intruder can't use their IP address to get through your firewall. So make sure you set up your rules correctly. Deny traffic. You have a rule set that, and this is basically what you see in most firewalls and routers, is it's called an implicit deny. Sometimes it's called a default deny. So I have a list of rules. So one rule says if traffic is coming from 8.8.8.8 and it is TCP or UDP port 53 and it's bound for this subnet, then allow the traffic in. And then there's another rule that says deny everything else. And that's what you want, a default deny. Log everything, syslog, SIM servers. Don't use things like FTP. Make sure that you review all inbound, outbound traffic. You always need to double check and make sure what you're writing as firewall rules and your configuration is appropriately done. Make sure that you know the source and destination IP address and ports. That address and the port put together it's called a socket. You want to make sure you understand every socket connection. Notify your security policy administrator about firewall changes. You need to document things. And you need to make sure that if you come up with an innovative idea, that it can become policy. And next thing we do is control physical access to the firewall. Because remember, if you can touch it, you can pwn it. You can own that firewall. Regularly back it up and regularly audit that firewall. And then in terms of evasion, what we're going to do is do behavioral analysis, deep learning. We're going to do network segmentation. What do you mean network segmentation? Well, let's say that I have a network and there are 2,000 computers on the network and they're all on the same subnet. If there's a worm in that subnet, it'll spread to 2,000 computers. But what if I broke that up into network segments of 20, right? We just make a lot of network segments. If there's a worm on one segment, it can only hit 20 computers. So network segmentation is extremely important in network protection, and that would include firewall structures like perimeter networks, DMZs. So make sure we do that principle of least privilege, multi-factor authentications, encryption with VPNs, code signing, using certificates, making sure that we only allow specific MAC addresses for certain types of functions, monitoring our network in real time, making sure that all of our most important files are monitored at all times, that we have data loss prevention, that DLP. And so if somebody accidentally tries to exfiltrate information, like for instance, let's say I get a really exciting email at work and I decide, you know what, I want to show this to my friend, and I forward it to my friend, and little did I know, but there's information that should not have left the company. DLP will stop that from going out. Restrict the transfer of sensitive information. So those are some of the things we need to do. You have just finished this module. It's amazing. And you did a good job working your way through it. There's a lot of low-level information. We're going to see a similar low-level. When I say low-level, I mean that we're looking at code. We're looking at programmatic processes. We're looking at memory hooks. We're looking at the document object model. We're looking at snippets of C code or Visual Basic for applications. Later on, we'll be looking at SQL. And those take a lot of, they're kind of very low level. It's not a high level concept. So thanks for bearing with me through that. And now we've talked about how to both use techniques to get beyond IDSs, IPSs, and firewalls, to get beyond network access protection and EDR, and by extension XDR. And now what we're going to do is we're going to practice some of this in the laboratory. So follow me to the lab and then join me in the next module.